Okay, we're going to do example 4 on the absolute extrema notes. A particle moves along the x-axis with position x of t equals 0.1 t squared minus t plus 2 when 0 is less than or equal to t, which is less than or equal to 6. At what time t is the particle furthest to the left and furthest to the right? So our function that we're given is a position function. When we're asked when is the particle furthest to the left, we're asking when is the position of the particle minimum. When it's furthest to the left, that's when its position would be minimum. When we're asked when the particle is furthest to the right, we're asking when is the position of the particle maximum. So this problem is asking us to find an absolute max and an absolute min of the function given. It just doesn't use those words. So we're going to use the same process that we did yesterday. We're going to first take the derivative to find the critical numbers. So x prime of t, using the power rule, we're going to get 0.2t minus 1. Our critical numbers are values of t that make the derivative 0 or undefined. This is a linear function. It's never undefined. So we just need to determine when our derivative is equal to 0. It's going to be a lot easier when we're doing this problem if we don't have to divide by a decimal. So what we're going to do is we're going to take this entire derivative and multiply by something to get rid of the decimal. So let's think about what number could I multiply 0.2 by to eliminate the decimal. 5 is a good choice, because when I distribute that 5 through to the entire equation, I'm going to get 1t minus 5 equals 0. No more decimals left in the problem, so we can easily see that our critical number is t equals 5. So now that we have our critical number, when does an absolute, or where does an absolute max or min occur? Y'all know this. An absolute max or min can occur at critical numbers and endpoints. Get that down on your paper, please. Every problem that you do on this homework assignment, please justify by saying an absolute max or min can occur at critical numbers or endpoints. We just want to commit that to memory and get that habit ingrained. Okay, now we're going to take our critical number and put it in a table along with our endpoints. Because, like we just wrote down, our absolute max or min can occur at the critical numbers and at endpoints. So the t values in our table are 0 and 6. Those are our endpoints. Our critical number lies between them, so we put that in our table also. We're going to input these values into the original function, x of t. So plugging in x is 0, that's going to be 0.1 times 0 squared minus 0 plus 2, because we're plugging in the 0 into that original function. That gives us 2. So at time 0, the particle is at a position of 2. Okay, plugging in 5, 0.1 times 5 squared minus 5 plus 2. So 5 squared is 25. 25 times 0.1 is 2.5. Minus 5 plus 2. The minus 5 plus 2 combines to negative 3. So adding these together, 2.5 minus 3 is negative 0.5. Okay, let's input 6 for t. So 0.1 times 6 squared minus 6 plus 2. In PEMDAS, exponent comes before multiply. So squaring the 6, we get 36. Times 0.1 is 3.6. Then we have a negative 6 plus 2. So that's minus 4. So 3.6 minus 4 is going to give us a negative 0.4 in our table. Good. We have all the information we need to answer the question. Again, the question asks at what time t is the particle furthest left. So the particle is furthest left when t is equal to, well, the smallest output in the table is negative 0.5. So t is furthest left, or the particle is furthest left at t equals 5, and at that point, it's at a position of negative 0.5. You don't have to tell the position. I'm just offering a little bit of information there. Okay, the particle is furthest right. It's furthest right when its position is maximum. So looking in the table, its position is maximum. That's the biggest output. So its position is maximum, or it's furthest right when t equals 0. At that point in time, it's at a position of 2. Okay, we've finished the question. I would like to ask a follow-up question. So the follow-up question that I'd like to ask is, what is the distance traveled by the particle on the interval 0 is less than or equal to t, which is less than or equal to 6. So that's our follow-up question. Okay, so the derivative of position is velocity. So we set this velocity function up here equal to 0, and we solved it to get our critical number. So this is the only time that that particle is at a velocity of 0, since the derivative equals 0. So that's the only time the particle changes direction. So the particle starts on the x-axis at a position of 2. At time 0 is at a position of 2. The particle then moves to the left until it gets to a position of 0.5. So we're just using the information from the table and determining that the particle moved left from a position of 2 to a position of 0.5, negative 0.5. So it traveled a distance of 2.5 units left. Okay, next the particle traveled from negative 0.5 a little bit back to the left and ended up at a position of negative 0.4. So it moved an additional distance of 0.1. So what's the total distance traveled by the particle? 2.6.